Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, of course, long back we are back to this machine learning series. Yes, dear friends, today we are going to have a summarization on statistics and then we just move on towards probability. Okay, so this exact purpose of session is to develop your knowledge of basic statistical techniques and methods and how to apply them to develop the business and personal intelligence that will help you make a decision. What is the exact requirement of learning statistics? Yes, dear friends, actually it required so many majors. The first reason is that, numerical information is everywhere, and of course, the second reason for taking a statistic is that statistical techniques are used to make decisions that affect our daily life. And how do we define the word statistics? Dear friends, we encounter it frequently in our everyday language. It really has two meanings. In the more common usage, statistics refers to numerical information. Yeah, that is what I have just already specified. And here I just give you a small examples that include the average starting salary of a graduate, or the number of deaths due to COVID in the pandemic years. Or in this example, statistics are a value or a percentage. And here other examples, you can just specify the mean time waiting for technical support is 20 minutes, or the mean length of a business cycle since 1945 is 61 months. Yes, these are all example of statistics. We frequently present statistical information in a graphical form. A graph is often used for capturing reader attention and to portray a large amount of information. Of course, dear friends, statistics is about collecting and processing information to create a conversation, to stimulate additional questions, and to provide a basics for making decision. And here I just want to let you know what is the type of statistics. Different type of statistics depends on the question asked and type of data available. Unorganized data is of little value as is, but descriptive statistic can be used to summarize the data and provide information that is easy to understand. Yes, dear friend, as I have specified, it is divided into two categories. One is descriptive statistics and inferential statistics. Here, the definition of a statistics given earlier, that is referred as like organizing, presenting, analyzing data. Of course, this phase of statistic is usually referred to as descriptive statistics. And when coming to masses of unorganized data, such as the census of population, the weekly earnings of a thousand of programmers, and an individual response of a registered voter regarding their choice of president of a country, or the little, of course, are the little values as is. However, statistic techniques are available to organize these type of data in a meaningful form. So now data can be organized into a frequency distribution. And I just come towards this page again. Yes, dear friend. Before that, I just want to specify the next example, that is next category of type of statistics, that is inferential statistics. Yes, the second type of statistics is inferential, also called as statistical inference. Our main concern regarding this inferential statistics is finding something about a population from a sample taken from that population. Of course, this inferential statistics, I have just given the definition here. The method used to estimate a property of a population on the basis of a sample. See, note the word population and sample in the definition of inferential statistics. In statistics, the word population has a broader meaning. A population may consist of individual, such as that what we have just said, a student enrolled to this university, or a CEOs from a Fortune 500 companies. So a population may also consist of objects. And here the measurement of interest might be scores on the first examination of all the students in the statistics. Or yes, a population here, Simon, I'm just specifying, dear friends, a population in the statistical sense does not always refer to people. Here, what is population? Yes, again, I just go here, dear friends, population, the entire set of individuals or objects of interest or the measures obtained from all individuals or object of interest. And here, what is sample? Yeah, the portion or a part of the population of interest. Why take a sample instead of studying every member of the population? Different, a sample of registered voter is necessary because of the prohibitive cost of contacting millions of voters before an election. And one more example, testing wheat for moisture content destroys the wheat, thus making a sample imperative. As noted, using a sample to learn something about a population is done extensively in every part of field, whether it is business or agriculture or politics, and even we can just add up towards the government. And here the relation between a sample and a population is portrayed here. Kindly just have a look. We wish to estimate the mean miles per gallon of an SUVs. What we just done? Only just 6 SUVs alone. We have just 6 SUVs are selected, and here it is just selected from this the population, and here what we just have the sample, and here the mean MPG of the 6 is used to estimate this MPG of the population. So this is how you can just make use of that population and towards the sample. Yes, going back to types of variables. Dear friends, there are two basic type of variables, qualitative and quantitative. When the characteristic being studied is non-numeric, yes, of course, it is specified as like qualitative. Okay, it is specified as like qualitative, and you can also specify it as like an attribute. And here I just give you small examples of qualitative as like gender or religion affiliation or type of automobile owned, and state of birth and eye color. Okay, so when the data are qualitative, we are usually interested in how many or what percent fall in each category. For an example, what percent of population has blue eyes, or what percent of total number of cars are sold last month were in SUVs. So here qualitative data are summarized in charts and bar graphs. I just add up here quantitative. When a variable studied can be reported numerically, of course, the variable is called a quantitative variable. And here also I just add up with some examples of quantitative, or the balance in your account, or the age of company presidents, or the life of an automobile battery, okay, and the number of children in a family. So here what we are specifying towards this quantitative and qualitative is, kindly just look on towards this chart. Yes, quantitative variables, and further again I'm just going to categorize as like discrete or continuous. And here discrete variables are assumes only certain values and there are gaps between the values. For an example, discrete variables or the number of bedrooms in a house. Yes, you can just specify number one bedrooms or two bedrooms in a house or like that. Or the number of cars arriving in any as like if you just specify exit number 5 or exit gate 5. Or in a hour, how many cars are there? So, and the number of students in each section of a statistical session, like that you can just specify. So that, yeah, 25 from section A, 42 from section B, and 18 in section C. Exactly, we count. For example, the number of cars arriving towards this exit 5. Yeah, you can just say, yes, of course, we can just specify arriving as like this count of statistics students, or the notice that how that can be as 3 or 4 bedrooms. But you can just specify as like 3.5 bedrooms or 3.76 as bedrooms, or even though if you just specify this exit gate, you can just say as like 7.34 cars. Are you able to just say? No, you are not. Yes, dear friends, of course, there is a gap between possible values, but here typically discrete variables results from counting. An observation of a continuous variable can assume any value within a specific range. And here, of course, example of continuous variable or the air pressure in a tire and weight of a shipment of any products, you can just say. Or examples are the amount of resin bran in a box and the duration of flights from you can just say Orlando to San Diego. Grade points average is a continuous variable. Yes, we could report the GPA of a particular student as like 3.5% or 3.7%. Like that you can just say. The usual practice is to round to what we just do. Yeah, of course, we just round to 3 places. So typically continuous variable results from measuring. Dear friend, why I am just saying these much of examples? Yes, dear friend, kindly just observe one thing. Whenever you just specify the statistics, yes, you are going to apply in various fields. So, yes, examples or a definition, yeah, place it in everywhere, every interdisciplinary concept, and just understand what is the behind concept. Let me just make towards the level of measurement. Dear friend, data can be classified according to level of measurement, and the level of measurement will determine how the data should be summarized and presented. And according to level of measurement, dear friends, as I have already specified, the level of measurement of a data dictates the calculation that can be done to summarize and present the data. So here it will also determine the statistical test that should be performed. For an example, let me just go ahead with one of the things. So here, of course, you are all aware, M&M's, if I just choose a bag of candies in a bag of M&F, how many? Okay, there are 6 colors you can just specify, okay, 6 colors of candies in a bag. Suppose we assume brown values, let me just have us like brown value is 1, yellow is 2, and blue is as like 3, orange as like 4, let me just have green as like 5, and I think one more color, red is 6. So from a bag of candies, we just add the assigned color value and divide by the number of candies and report that the mean color. If we just take, okay, number of this number of red color, this number of brown, blue, yellow, orange and green. If I just specify 3.56 is the mean. Does this mean that the average color is blue or orange? Is it so? If I just specify 3.56, it is just going to result that is 3 and here for blue and orange is for 4. So yes, this average color is blue and orange? Of course not. As I already specified, dear friends. There are so many examples here. One more I just add up with an example. In a high school track meet, okay, there are 8 competitors in a 400-meter run. We report the order of finish, and that the mean finish is 4.5. What does the mean finish tells us? Nothing. In both of these instances, we have not properly used the level of measurement. There are actually 4 levels of measurement, dear friends. That is nominal, ordinal, interval and ratio. Yes, I'm just going to make it here as like a summarization to that end. Before that, let me just see what is the nominal level. And here adapting with that, yeah, the lowest or most primitive measurement in the nominal level, and the highest or the level that gives us the most information about the observation. So that is the ratio level of the measurement. Okay, so before going on to summarization, let me just have what is this nominal level data. Dear friend, for the nominal level of measurement, observation of a qualitative variable can only be classified and counted. So there is no particular order to the label. The classification of 6 colors of M&M's candies is an example of a nominal level of measurement. We simply classify the candies by color. There is no natural order. That is, we could report the brown candy is first, or the orange candy as like first, or any other candy as like first. And if you just take it, gender is another example of a nominal level of measurement. Suppose we count the number of students entering a football tournament game with a student ID, and report how many are men and how many are women. Yeah, we could report either the men or the woman first. So, dear friend, I just want to add up with this property. The variable of interest is divided into categories or as like outcome. There is no natural order to these outcomes. Let me just go for the next one, ordinal. Dear friend, the next higher level is the ordinal level. And I just want to specify here, yes dear friend, let I just give you a small tabular here. If I just want, say, a list of student rating a professor. Yeah, rating a professor, and each student in the class answered the question, overall, how did you rate the instructor in the class? And of course, the variable rating illustrates the use of ordinal scale of the measurement. Okay. One classification is as like, let I just make it, yes, superior, okay, and let me just have the good, average, okay, poor and inferior. Okay, here, what is the frequency of providing this? Okay, 6 rated as superior, 28 rated as good, and 25 members rated as average, and 12 for poor and 3 as inferior. Okay, so this is what has like rating. Okay, now kindly observe, dear friends, that is superior is better than good, and here good is better than average, and so on. However, we are not able to distinguish the magnitude of the difference between groups. Is the difference between superior and good the same as the difference between this poor and inferior? We can't tell. If we substitute 5 for, if I just specifying as an 5 ratings for the superior and 4 here for good, we can conclude that the rate of superior is better than the rate of good, but we cannot add a ranking of superior and ranking of good, with the result being meaningful. Further, we cannot conclude that a rating of good, that is 4 here, is necessarily twice as high of this poor, because here it just comes as like 3, 2, 1. So see here, if it is poor as 2, it should not be as like twice that of rating of this good. We can only conclude that a rating of good is better than the rating of poor. We cannot conclude how much better the rating is. Okay, yes dear friend. And next here it is going on to a interval level data. Yes dear friend, here also interval level of data or measurement. Yes, it is the next highest level, and it includes all the characteristics of the ordinal level, but in additional, yes, the difference between the values is a constant size. An example of an interval level of measurement is temperature. Suppose the higher temperature of an let me just have some 3 consecutive winter days in any one of the location, or let me just take it as like a Boston. Yes, one among things are 28, 31 and 20 degree Fahrenheit. So these temperature can be easily ranked, but we can also determine the difference between the temperature. This is possible because yes, 1 degree Fahrenheit represents a constant unit of measurement. Equal difference between two temperature are the same, regardless of their position on the scale. That is, difference between, if I just specify 10 degree Fahrenheit and yes, 15 degree Fahrenheit, yes, it is, the difference is 5. And to the same thing, if I just go for difference between 50 and 55 degree Fahrenheit, it's also 5 degree. It is also important to note that here 0 is just a point of scale and it does not represent the absence of the condition. Because 0 degree Fahrenheit does not represent the absence of heat, just that it is cold. In fact, 0 degree Fahrenheit is above, of course, minus 18 degree on the Celsius scale. Okay, towards ending up with the properties. Yes, dear friend, the properties of this interval level of measurement is, yes, data classification or ordered accordingly to the amount of characteristic. Here I have already specified the characteristics they possess. And equal difference in the characteristics are represented by equal difference in the measurement. And yeah, next, moving on to the ratio level. Yes, practically or quantitatives. Of course, all quantitative data is recorded on the ratio level of measurement. And dear friends, almost all quantitative or ratio level, the 0 point and the ratios between the two number is meaningful at this level. And this ratio level is the highest level of measurement. And as I have just specified, the interval, it has all the characteristics of that interval level. But in addition, the 0 point is meaningful and the ratio between the two numbers is meaningful. So here, with added towards the example, dear friends, a ratio scale of a measurement includes wages, unit of production, weight, changes in a stock price, or distance between the branch office, and you can also add up one more, height. So here what it is just resulting, what these examples are resulting. Yes, money is a good illustration. When we just take in towards this ratio level, money is a good illustration. If you have $0, then you have no money. Weight is another example. If the dial on the scale of a correctly calibrated device is at 0, then there is a complete absence of weight. So the exact ratio of two number is also meaningful. Yes, add up within the properties. Dear friends, this exact characteristic or the data characteristics, the classification are ordered according to the amount of characteristics they possess. And kindly just observe here, equal difference, always that equal difference in the characteristics are represented by equal difference in the number assigned to this classification. And of course, the last one, the 0 point is the absence of characteristics and the ratio between two numbers is meaningful. So kindly just be aware of where you are using, which measurement you are using. And of course, I just summarize here, dear friends. Yes, this is the exact summarizing the 4 level of measurement. And yeah, we are just going to analyze each and every level of data in further examples. Okay, yes. Moving on to next one, dear friends. Here in this part, we are going to use in data, that is describing data. We are going to demonstrate how to create a frequency table and frequency distribution. And then the grouped data is presented graphically. So that is what the exact forthcoming session. Yes, let me just enter into this. Here, how to construct a frequency table. Before going on to that, I just want to specify one simple word. Frequency table are used in descriptive statistics. For what? Yeah, to show the pattern of the data. And here identify where values tend to concentrate and expose extreme or unusual values. Okay, let me just take here. Here we are having as like in some auto group data. Okay, and each of has as like 4 dealership. Okay, and what is the thing is the number of cars sold in each location. Yes, before going on to that, I again just make a small descriptive towards this constructing a frequency table. Kindly just listen, dear friends. Recalling from the previous techniques which we just used to describe a set of data, which we just say descriptive statistics. And to put it another way, descriptive statistics organize data to show the general pattern of the data and where values tend to concentrate and to expose extreme or unusual data values. So the first procedure we discuss here, it is the frequency table. And of course, dear friend, kindly just have a note of it. Grouping of qualitative data into mutually exclusive classes, showing the number of observation in each class. Yeah, that is what. And here, yeah, we distinguished between what is qualitative and quantitative variables. And to have a review, a qualitative variables is non-numeric. That is, it can only be classified into distinct categories, and there is no particular order to these categories. And here, example of qualitative data include as like yeah, you can just have republications or independent states, or you can just say method of payment for a purchase. Yeah, of course, cash or check or debit or credit card, or another hand, quantitative variables are numerical in nature. And here example of quantitative data relating to what we can just say, yeah, something as college students include something products, what they just usually have as like prices of their product, that is textbooks, or you can just say their age, and the hours they spend studying in each week of the semester, whatever be. Let me just take back towards this. If you just take here auto group data set, of course you can also have something as like variables, yeah, each and every vehicle sale, and what is the age of buyer, or amount of profit. If you just sell this vehicle, na, what would be the amount of profit? Or yeah, you can just go for dealer that made on the sale, or the type of the vehicle sold, and the number of previous purchase by the same buyer. So the dealer and the type of vehicle are qualitative variables, and here the amount of profit, the age of this buyer, and the number of previous purchase of are exactly quantitative variables. And dear friends, to summarize these qualitative data, we classify the vehicle sold last month. Here I have just given you. okay, last month according to their location. And we use this location to develop a frequency table with 4 mutual exclusive classes. So this means that a particular vehicle cannot belong to more than one class. So each vehicle is uniquely classified into one of this four location. Okay, so that is what specified. This is the frequency table. Now, let me just relate it. Let me just relate. So here you can convert that class frequency to a relative class frequency to show the fraction of total number of observation in each class. A relative frequency also just captures the relation between the class total and the total number of observation. Let me just go back towards this. So see here, if I just make use of this particular and I just make a summarization of relative frequency. So see here, in this vehicle sales example, we may want to know the percentage of total car sold at each of the 4 location. So here, to convert the frequency distribution to the relative frequency distribution, each of the class is divided by the total number of observation. And here the fraction of the vehicle sold last month, for an example, if I just specify 52, so here it is 52 divided by 180, and this is 40 divided by 180, 45 divided by 180, 43 divided by 180, and what would be the fraction? Of course, the relative frequency of each fraction. Here I have already made a small calculation. I just take it towards here, and it is 0.289, and this is 0.222, and this is 0.250, and this is 0.239. And for your information, when you just add up, I just get the value 1 to the top end. So this is what the exact relative frequency of each location. Here it is shown in this table. Now let me just make it as like a graphical representation. To the same, dear friends, actually the most common graph form to present a qualitative variable is this bar chart. Okay, so in most cases the horizontal axis shows the variable of interest, the vertical axis shows the frequency or fraction of each of the possible outcomes. A distinguished features of this bar chart is there is distance or a gap between each bar, and that is because the variable of interest is qualitative. The bar are not adjacent to each other. Okay, so thus a bar graphically describes a frequency table using the series of uniformly wide rectangle, where the height of each rectangle is called the class frequency. And here's to have a small definition. Yes, dear friend, a bar chart, a graph that shows qualitative classes on the horizontal axis and the class frequency on the vertical axis. Let me just have here the same auto group data, and kindly just have a note. The variable of this interest is the exact location, and at each location is the class frequency. Here it is just specified it. And we label the horizontal axis with the 4 location and scale the vertex with the numbers sold. And dear friends, kindly observe the height of the bar or the exact see, actually here each location, when we just specify this height of the bar or rectangles corresponds to the number of vehicles at each location, and yeah, we would just take it for 1 by 1 if you specify. Yes, dear friends, it just shows the bar chart of this. And of course, I just want to add up this. The variable here, the location of this nominal scale. So the order of the location on this horizontal axis is doesn't matter. K, O, S and T. It is not in alphabetical. Okay, so listing this variable alphabetical or by some other type of geometrical or geographical arrangement might also be appropriate. Okay, so next let we have one more. It is pie chart. Dear friends, another useful type of chart for depicting this qualitative information is this pie chart. And here, let me just have some more examples here. It is specified. Kindly just observe here the details of constructing this pie chart using this information. What it is the breakdown expense of an some here huge state lottery expense that has been done in 2009. Okay, the first step to develop a pie chart is to record the percentage as like 0 or 5 or 10 or 50 and so on evenly around the circumference of the circle, that is exact towards this circle. And first of all, what it is 60% awarded for prizes. Okay, kindly just draw a line here. So this is 60. So I'm just going to draw it from this. I'm just making it as like a 60% of the whole. And here the area is the exact slice, represents the lottery process that were awarded in the prizes, that is 60%. Next, add the 60% expense to the 29% payment for education. So if you just do 29 add up, kindly just observe this is 60 plus 29. So here it would be as like from here to here it would be 89%. And yeah, this exact depicts the payment made to education. And continuing add the 6% for bonus, and yeah, which it just gives the 95%. And yeah, so the slice between this 89 to 95 represents the business of this bonus. Yeah, the remainder 5% is also for operating some expenses. See, because each slice of this pie represents the relative shares of each component, we can easily compare them. The largest expense of this is prices. Of course, about 30% of this process is transferred to education. And if you just specify operating expense accounts for only 5% of the proceeds. So we can use software to quickly create a visually appearing and informative pie chart. But here, yes, of course, by using a small Excel itself, this exact table has been converted into the pie chart. And one more, dear friends, this pie chart and the bar chart serve much the same function. What are the criteria for selecting one over the other? Yes, in most cases, pie chart are the most informative when a goal is to compare it with the relative difference in the percentage of observation for each of the nominal scale variables. Okay, so when coming towards bar chart, yes, of course, it is our preferred when the goal is to compare the number of observation in each categories. Okay, yes, dear friend. Now let me just construct the frequency difference. And dear friends, we distinguish already. Earlier we just distinguished between qualitative and quantitative data. And here we summarized the qualitative variable as like location of sale or using the frequency table and the relative frequency table. And here till this bar chart. Yes. Here, the same, we are also going to the same data, that is auto group data, with just having several quantitative variables. I have already specified previously, as you can just say age of the buyers or what I just specified. Yeah, profit earned on a sale of a vehicle or the number of previous purchase. Here, if we just take it for an example, suppose Mr. Bal wants to summarize last month's sales by profit earned. What we have to do? Of course, we have to look on towards this frequency distribution. Of course, I have already specified the exact definition. Yes, a grouping of data, that is quantitative data, into mutually exclusive classes. So showing the number of observation in each classes. That is what frequency distribution. And how do we develop a frequency distribution? Yes, dear friends, the first step is to tally the data. Okay, tally the data into the table that shows the classes or the number of observation in each classes. And here the step is constructing a frequency distribution, or best described here. If I just specify a small thing, you remember that goal of constructing a tables or a chart and a graph. Yeah, that will quickly reveals the concentration or extreme values and mainly the shape of data. Let I just give one more thing. Dear friends, here kindly just observe. We are having a profit and towards the frequency. And what about this relative frequency? Yes, this 180 divided, which is going to divide it by with this 8. So here 8 by 180, 11 by 180, 23 by 180. Yeah, that is what the relative frequency. I just repeat once again, dear friend. It may be desirable, as we did earlier, the qualitative data, to convert class frequency to relative class frequency to show the proportion of the total number of observation in each class. And here in our vehicle profit, we may want to know what is the percentages of vehicle that are for an example. If I just specify what is the vehicle profit of this $1,000 up to $1,400 in a class. So in another study also we can just say, we may want to know what percentage of the employee used 5 up to 10 personal leave days for the last year. Or you can just convert a frequency distribution to a relative distribution, relative frequency distribution. How come? Yeah, each of the classes is divided by the total number of observation. Yes, and here for the distribution of this vehicle profit, here we have the relative frequency. For an example, if you just specify for this, that is $1,000 to $1,400, how you just specified? Yeah, dividing this 23 divided by 180. Okay, and what we just get? Yeah, we just get 0.128. That is, profit on towards this is 12.8% of a vehicle sold between $1,000 and $1,400. Here the relative frequency for the remaining classes also I have just specified here. Dear friends, kindly have a note and where we are and how we are constructing this frequency distribution. Next, I just go towards one more graphical histogram. Dear friends, histogram for a frequency distribution based on quantitative data, yes, is similar to the bar chart that is showing the distribution of a qualitative data. Okay, the classes are marked on the horizontal axis and the class frequency are on the vertical axis. The frequency are represented by this height of the bars. But however, there is one important difference based on the nature of data. That is, quantitative data are usually measured using scales that are continuous and not discrete. And here, therefore, the horizontal axis represent all the exact possible values, and the bars are drawn adjacent to each other to show the continuous nature of the data. So here it would be as like there won't be any gap. Okay, yes, let me just go towards frequency polygon. Dear friends, the frequency polygon also shows the shape of distribution and yes, and is similar to the histogram. It consists of a line segment connecting the exact points formed by the intersection of class midpoint and the class frequency. Now, the construction of a frequency polygon, let me just take the same profit which we just gone towards this previous. Okay, the profit, same thing is there. And what it is happen? Yeah, we use this, and here this midpoint of each classes is scaled on this x-axis. Kindly just observe, here we are having that midpoint. Okay, and the class frequency, or here it is specified as the y-axis. Kindly just recall that the class midpoint is the value of the center of this class. 200 and 600. What is the center? 400. Between 600 and 1000, 800 is the midpoint. Okay, so yes, dear friends, the class midpoint is the value of the center of the class and represents the typical value in that class. And here the class frequency is the number of observation in a particular classes. As noted before, see, actually previously we have just said 200 and 600, 400 is the mid. And here to the same thing, let me just have towards this midpoint, I have the frequency 8. So yes, here I am just making a dot. This is the exact point which we just is called as like coordinates. And here the coordinate of the next point or here as like x is 800 and y is 11. Kindly just observe, y is 11. And this process is continued for all classes, and then the process are connected in order. These are the exact connection. That is, the point representing the lower class is joined to the one representing the second class, and so on. And here, kindly just observe, dear friend, for the exact midpoint of this 0 and towards this 3600 are added to the x-axis to anchor the polygon at 0 frequencies. These two values, that is 0 and 3600, were derived by subtracting the class intervals of 400 from the lowest midpoint and by adding 400, 400. So to the highest midpoint as like 3200 in the frequency distribution. And here, dear friends, one more thing I just want to say. Both the histogram and the frequency polygon allows us to get a quick picture of the main characteristics of the data. What is the high, what is the low, what is the point of concentration. Although the two representations are similar in purpose, the histogram has the advantages of depicting each class as a rectangle with the height of the rectangular bar representing the number in each classes. But the frequency polygon in turn has an advantages over the histogram. So it allows us to compare directly two or more frequency distribution. Okay, next I just want to specify this cumulative frequency distribution. Dear friend, consider once again the same distribution of this profit, okay, on a vehicle sold by something and auto group data. Okay, suppose we were interested in number of vehicles that is sold for the property less than $1,400, or the property earned on the lowest selling 40% of a vehicle. So these values can be approximated by developing a cumulative frequency distribution. Okay, so and portraying it graphically in a cumulative frequency polygon. So let me just have this exact polygon. Kindly just observe, dear friends. As we previously, yes, we have done towards this each and every 8, and we have the points as 11, we have points as 23. So everything add upon towards this, we got this cumulative frequency. Okay, and to plot a cumulative frequency distribution, kindly scale the upper limit of each classes along the x-axis and the corresponding cumulative frequency on the y-axis. Okay, and here to the exact, to provide additional inference, you can also label the vertical axis on the left in the unit and vertical axis on the right in the percentage, whatever you want. Yeah, you can just go ahead, dear friends. And yeah, the vertical axis on the left, that is labeled here as 0, 20, 40 till 180. We have the points, and here towards the right, I have just specified the right from 0 to 100%. And here the value of 50% corresponds to that of 90 or 90 vehicles, whatever the thing we can. And dear friends, let me just begin the first one. Yeah, we have the plot is x is equal to 20 and towards y is 0. So I just make a point here. Okay, and none of the vehicles sold to a profit less than $20. So that the profit on 8, that is vehicle, was less than 600. Kindly just don't get confusion with this 200. It is lower point, so we have to take the higher words. Okay, so here that is what. And yeah, next one I have to just draw about the 19 vehicles that sold the profit less than 1000. So all these things we have just charted, and yeah, the rest of the points are plotted, and then the data, that is the once after the plots, yeah, let me just connected the dots, and yeah, here it forms the cumulative frequency polygon, dear friends. Okay, now next I just want to specify. Yes, dear friends, here we are concerned with two numerical ways of describing, that is quantitative variable and qualitative variable. And when describing this quantitative variables, mainly we are on towards discussing about measure of location and measure of dispersion. And towards this measure of location are often referred to as average. And here the purpose of measure of location is to pinpoint the center of distribution of data. And an average is a measure of location that shows the central value of a data. For an example, if we consider only the measure of location in a set of data, or if we compare several set of data using central value, yeah, we may draw an erroneous conclusion. So in addition to measure of location, we should consider the dispersion, often called the variation or the spread in the data. Dear friends, let me just begin with this measure of location. See, there is not just one measure of location. In fact, there are many. We will consider as like, in such a case, as like if we just go for mean, yeah, there is the arithmetic mean, the weighted mean, and geometric mean. And here we have the median and towards the mode. So the arithmetic mean is the most widely used and widely reported measure of location. Now we study the mean as both population parameter and sample statistics also. Okay, so let me just come one by one. So the first of all, it is all about population mean. Different many studies involve all the values in a population. Yes, and for raw data, that is data that have not been grouped in a frequency distribution. Here the population mean is the sum of all the values in the population divided by number of values in the population. So to find the population, what we have to do? Yes, sum of all the values in this population, and here number of values in this population. And instead of writing out in words, yeah, you can just have this as like a symbols, the summation of x divided by n. So that is what the mean. And any measurable characteristics of a population is called the parameter. And yeah, the mean of a population is example of a parameter. Okay, now sample mean. Of course, we just seen about the population mean. Here, let me just go for sample mean. Here, we often select a sample from the population to estimate a specific characteristics of population. And yeah, you can also give so many information related towards this. Yeah, kindly observe here for sample mean, you have to make it as like x bar, which is equal to summation of x divided by n. And here, dear friends, for raw data, that is ungrouped data, the mean of the sum, yes, the mean of the sum of all sampled values divided by the total number of sampled values. So that is what the mean of the sample and the mean of the population are computed in a same way, but the shorthand notation used is different. Yeah, previously we just had it as like a mu, and for n we just had an uppercase, and here kindly just to see the exact symbol what we just use it. Okay, and of course, dear friends, the mean of a sample or any other measure based on the sample data is called statistics. And if the mean weight of a sample, for an example, if I just say as like 10 jaws of strawberry jam is 41 ounce, if I just specify, of course, this is an example of an statistics. This is what we have already discussed. Yes. Now, arithmetic mean. Yes, dear friend, arithmetic mean is widely used measure of location. It has several important properties. Yes, every set of intervals or ratio level has a mean. Kindly just recall from the previous one, the ratio level data includes such data as ages or incomes or weights. What is that? With the distance between number being towards that constant. And the next one, all the values are included, all the values here, of course, are included in the computing the mean. And next one, yes, the mean is unique. That is, there is only one mean in the set of data. Later we are just going to discover. So kindly just have the average that might appear twice or more than twice in a set of data. And dear friends, yes, the sum of deviation of each value from the mean is 0. Sum of deviation is in the sense from this x minus x bar, which we just have specified this deviation from the mean, that is equals to 0. If I just specify, for an example, the mean is 3 and 8 and 4. What is the mean of this? Yeah, let I just specify with the mean is 5. How come just with this exact equation and here mean of the value is calculated? Yes, kindly just observe here it is 3 minus 5 because I am just specifying 5 is the mean for this 3 values. So 3 minus 5 plus 8 minus 5 plus 4 minus 5. What happens? This is minus 2. Plus 3 minus 1, and of course here it just results to 0. Thus we can conclude or we can consider the same mean as here as like a balance point for a set of data. See here we have a long board, here I have just numbered 1 to 9, okay, evenly spaced on it. Suppose 3 bars of equal weight were placed on the board, which we have just used as like previously. I have just specified 3, 8 and 4. Kindly just see here. Here I am just making equal weight of 3, 4 and 8 were placed on the board. Okay. Now, and balance point of this where to set? Yes, of course. Here this is the exact balance point where we can just set to make it. Okay, so this is how the properties of arithmetic mean is specified. Now next, let I just go to the median. Dear friends, the median is the value in the middle of a set of ordered data. and is often used to describe data sets where there are one or just a few extreme values. Even we can just say, such as with real estate price or household incomes, anything in a particular area. Okay, so we have stressed that for a data containing one or one or two very large or very small values, the arithmetic mean may not be representative. So the center for such data, here if I just specify, this is the exact center. The center for such data can be better described by a measure of location called the median. Here, to illustrate the need for a measure of location other than this arithmetic mean. Suppose you are seeking to buy an area in particular any location, let me just have, and your real estate agent says that the typical price of this unit currently available in any of the thing, let me just say as dollar or 110K. Would you still want to look? Yes, of course, if you have budgeted, your maximum purchase may be here. And what is the maximum purchase here if I just specify like this? Of course, maximum purchase, it would be as like a $70K. Okay, you might think they are out of your price range, or however, checking the price of an individual unit might change your mind. Kindly just observe here, it is $60K, $65K, 70K, 80K, and one super duplex penthouse, let me just have, it is $275K. And here, what is that arithmetic mean purchase? Of course, what I just specified, 110K. As a real estate agent just reported, but one price is this 275 is pulling the arithmetic value upward, yes, and causing it to be the unrepresentative average. It does seem that a price around here, that 70K, is more typical or representative age, and it is. In cases such as this, the median provides a more valid measure of location. And as I have already specified, kindly just have a note on this, dear friend, the midpoint on the value after they have been ordered. So how a median has to be calculated? Of course, first of all, you have to short it, and then you have to know the mid value. When you are having the odd value, yeah, easily you can just calculate the mid value. But when it is even, kindly just see, yeah, you have to take the average of the between two. Okay, so note that there is the same number of prices, even though if you just make it in ordered wise of ups and downs and ups, yeah, this exact value, as it has an odd aviation, yes, the central median of this particular data is $70K. Okay, and yes, dear friend, the major property of this median is it is not affected by extremely large or extremely small values. Therefore, the median is a valuable measure of location when such values do occur. And the next, yeah, it can be computed for ordinal level data or higher. Maybe this exact ordinal level data that can be ranked from low to high or high to low, na? So it is an ordered way. So that is what meant for this median. Here you can just move on towards ordinal scale of measurement. Okay, next it is the mode. Dear friend, mode is another measure of location. I have already specified, yes, here we have the mode, the values of the observation that appears most frequently. The mode is especially useful in summarizing nominal level data. As an example of it, use of this nominal level of data. See, here I have just specified a company has developed something as 5 numbers of bath oils. The bar chart here, it just shows the result of a marketing survey designed to find which bath oil consumers prefer. Yeah, the largest number of respondents favored here is Lemo. Yes, of course, as evidenced by the highest bar. So that this exact value is the mode of this data. So this is how you can able to just check for the value for mode or whatever the exact location. And yes, when we just compare with this relative position of this mean or median and mode, kindly just think one particular information, dear friends. When you just go towards it, yeah, if you have the mean value, median value and the mode value, if everything are equal, yes, we have a symmetric distribution, which we just say yes, normal distribution. Of course, you can also specify this as like an bell curve model. Okay, and when you just go towards if you are having a skewness, if you just specify one among the thing as like mode is lesser than towards the mean value. Mode is lesser than towards the mean value and median value. Yeah, it is specified as like it is a positively skewed. And when you just go towards one, kindly just see if mode is higher, it is negatively skewed. So this is how you can just make it a relative positional. And dear friends, kindly just see here this distribution, that is the negatively skewed or positively skewed. It just shows that the distribution, how the distribution of data it is specified, and the mean should not use for representation of data. Okay, so kindly just have a note on towards that. And here I have just specified one among a calculation as like a weighted mean. And if I just want to make a small calculation, kindly observe, dear friends, a weighted mean is found by multiplying each observation, that is x by its corresponding weight w. Okay, so in such a case, I have to multiply each and every observation of that and to be divided by the summation of that particular. So here I just give you a small example. What is the car construction company pays its hourly employees? So these are the things, $16.5, $19, $25 per hour, and there are 26 hourly employees as like 14 are paid at 16, 10 are paid at 19 and 2 are paid at 25. Now kindly just observe what we just get from this, output. Yeah, how you just hourly rate this among the 26 employee. So to calculate the weighted mean, yes dear friends, kindly just observe here among this 14, we are just going to multiple it with 16.5, and for the 10 it is a multiple with 19 and 2 multiple with 25, yes, and divided with this 26 number. And of course here the weighted mean hourly rated per employee, it is $18. So this is how you just specify how come you can just calculate what is the weighted mean. And just a simple application. This is how the questions are being discussed when a statistics formula, or this is just like a word program. Okay, kindly have a note, dear friends. Let me move on to geometric mean. Dear friends, geometric mean here, see, it is useful in finding the average change of percentage or ratios indexes or growth rate over time. It has a wide applications in business and economics because we are often interested in finding the percentage. We are often interested in finding the percentage changes in sales or salaries or economic figure. So here, if we just specify like that, yes, of course, such as the gross domestic product, so which compound or built on each other. Here, let me just take a small geometric mean of a set of n positive numbers is exactly defined as like nth root of that product of n values. Nth root of that product of that values, and here I have just specified the exact geometric mean, and here yeah, you can also have the application of geometric mean, that is to find an average percentage change over a period of time. For an example, if you just specify here, I just give you one small thing here, dear friends. If you earned $30K in 2000, okay, and $50K in 2010, what is your annual rate of increase over that period? How would you just make it? Yes, dear friends, here this n, of course, you just take it towards the n between this 2000 to 2010. Actually, it is, if you just take it towards this, it is 9 years. Okay, 0 to 2009, it is actually 9 years. Okay, and 10 years, of course. And towards this 10 years, if you just want to make it towards value at the end of the period and value at the starting period. So here, if I just say $50,000, and here it is $30,000 minus 1. And if I just resultant with 1 second, dear friends, it is 50K divided by 20K and minus 1 to that whole root of 10 years. I just get 5.24%. So here the rate of interest or rate of increase is determined from the exact formula. So kindly have a note on towards this, dear friend. And next, it is all about study of dispersion. Yes, dear friend, this exact study of dispersion, we will have several measurements of dispersion. The range is based on the largest and the smallest value in the data set. That is, only two values are considered. Okay, so here the mean deviation, the variance, and the standard deviation, just use all the values in a data set and are all based on this deviation from the arithmetic mean. Let I just, of course, here the range, the simplest measure of dispersion is the range. It is difference between the largest and the smallest value. So here we have already known that is maximum value minus minimum value. And here the range is widely used in statistical process control, that type of applications, because it is very easy to calculate and understand. So for that it is very much easy calculated. And when you just go towards the variance, difference, the variance and standard deviation are also based on the deviation from the mean. However, instead of using the absolute value of the deviation, the variance and the standard deviation squares the, okay, the standard deviation squares the deviations. And kindly just have a note on towards this, the variance, actually the arithmetic mean of a squared deviation from the mean. That is what it is described it. And yes, of course, the variance is non-negative and is 0 only if the observations are all same. And let I just go with the population variance. See the formula for the population variance and the sample variance are slightly slightly different. See, the population variance is considered first. Kindly just recall the population previously we have just seen. Yeah, it's gone before. Okay, fine. Here the population variance is just found as like, yeah. So this is noted towards this being by finding the mean. That is what the first point. Begin by finding the mean. Find the difference between each observation and the mean, and square the difference. And next, yes, of course, you have to sum all the squared, that is what here, and divide the sum of squared difference by the number of items in the population. So you might think of this population variance as the mean of squared difference between each value and the mean. So for population whose values are near the mean, yeah, the variance will be same. For the population whose values are dispersed from the mean, yeah, the population variance will be large. So the variance overcomes the weakness of the range by using all the values in population, whereas the range uses only the largest and the smallest. We've overcome the issues by exactly here. If we just specify summation of this, if I'm just making towards mu, which is equal to 0, yeah, by squaring this difference, yeah, instead of using the absolute value, squaring the difference will always result in a non-negative values. Just kindly have a note on towards this. That is what the main thing which we consider towards here. Okay. And this is standard deviation. Yes, dear friend, sample standard deviation is used as an estimator of the population standard deviation. As noted previously, the population standard deviation is square root of the population. Just one last thing, a square root of the population variance. Likewise, the same, the sample standard deviation, it is the square root of the sample variance. Okay. So the standard sample standard deviation is mostly determined by this exact formula. Okay, so kindly have a note on towards this, dear friend. And yeah, dear friends, here I just want to specify just a particular thing. See, the formula for sample this simple and square root of this variance and the symbol, all these things we just see here. And towards that, standard deviation is most widely reported measure of dispersion. Okay, so these properties are useful for understanding both population standard deviation and sample standard deviation. Okay, so kindly just have note on towards this, why we are using this and where we are using this, each and everything. There is a particular functionality. Okay, and yes, dear friends, last but not least, let me just have something. The formula, mainly this exact formula is arithmetic mean of grouped data. See, this formula is used to find an esteemed mean of data in a frequency distribution. Once the data has been grouped in classes, yes, individual values are no longer available. So letting the midpoint of each class represents the value in each group. So multiply the midpoint by, of course I'm just making here, multiple the midpoint by the class frequency for each group, and then sum these product and then divided by the total number of frequencies. That is what here it is specified. And yes, dear friend, to calculate this standard deviation, if it is for a grouped data, yes, to calculate it, we need into a frequency distribution. So we need to adjust the exact formula slightly. So we weight each of the squared difference by the number of frequency in each classes. So previously we have just done this summation of Fm divided by n, and here towards the standard deviation for this grouped, kindly just see here summation of f mean minus towards that mean. That is the sample mean, the designation of the sample mean. Okay, and here what it is happening, of course, we are taking that exact profit, and from that profit you are having that is this frequency is provided. Of course, you are calculating the midpoint, which is between the exact midpoint of each and every profit value. And yes, this exact class frequency to the top midpoint, it is calculated here. And how this is each and everything, it is calculated from this point. And kindly observe, towards this mid minus of this mean, we just get this value. And squaring that, okay, and producting it with this frequency, we just get this value. And kindly just observe, dear friends, we are going to find the standard deviation with this exact formula. So subtracting the mean from the class midpoint and squaring the difference between the class midpoint and towards that of mean, and multiply the squared difference between the class midpoint. So this is step 1, and here we are just going for step 2, and the step 3 is multiplying, and the mean by the class frequency is step 3, and to the last one, sum the each and every value. Sum the value of this. This is the step 4. Once for all, yeah, to find the standard deviation, what we have, 7616 as I have already specified here, and 180 minus 1, yeah, we are just getting 652.33. So this is the exact standard deviation of the point. Okay, let me just make it with Python programming, how we are just going to create a frequency distribution, and let me just also have a small demo by using this Python programming. Let me just have an cumulative frequency distribution. So yes, dear friends, here we are just going to create a frequency distribution. And as we have already seen, yeah, the frequency distribution indicates the frequency of occurrence of various outcomes in the sample data. Sometimes the frequency distribution is displayed as a plot or a graph. So we can either use a bar chart or a histogram to plot the frequency distribution. And each entry of this distribution shows the frequency of occurrence of different values within a specific group. And let me just have an sample. So here it is the weight range, and we have the exact data as like, so see here, less than 50 kg, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and yes, 90 to 100. Yes, this is the exact data, and with the frequency, number of student, is it the exact frequency? Okay, and with this, let I just create a tabular column. So yes, kindly observe, dear friends, here it is the weight up to, so less than 50, 50 to 60, so 60 to 70, 70 to 80, 80 to 90, and 90 to 100. And here kindly just observe, this is the frequency. Let I just have it here. Kindly observe 4, 15, 20, 22, 5 and 2. So that is what here. Let I just include that here also. So 4, 15, 20, 22, 5 and 2. Okay, now let we utilize this, and let we using this, let me just make a bar chart to plot this exact frequency distribution. Kindly just observe here, dear friends, this by using this both the data, we are just going to plot a frequency distribution, and with that x and y as an attribute, we are going to plot an bar plot. And here I'm just providing the X label, Y label, and towards the title. So let me just see the exact chart. Okay, so kindly just observe. So the bar chart that takes values of X and Y axis, and here the plot and plots the value of X and actually Y as a vertical bar. Okay, and here we have the informations of both X and Y, and here we use a bar chart to show the frequency distribution. Okay, so however there are cases when we do have values for X axis but we don't know what values of X they belong to. So in such a case, in this case, yeah, it is more convenient to use the histogram to plot the frequency distribution. Yes, let we take in such a case, yeah, we just go towards this frequency distribution by using histogram. And dear friends, this histogram splits the data into small equal sized bins. Okay, so for that we can just provide what is the number of bins and place the frequency of occurrence of a Y variable in the respective bins. And yes, we do have the option to change the number of bins for a better displayment of data. And here let me just have it. So yes, dear friends, we are going to have a random number, and as any one of the thing, as we know what values of X in such a case, or we do have values for the Y axis, but we don't know the value of Y axis or X axis. Yeah, we can make use of this histogram. And yes, what is the exact particular grid do you want, or what is the X label, Y label, and towards the title we have just provided here. And let me view the normal distribution. And here I just want to specify one thing, dear friends. Actually, in this example, we generated thousand data. Okay, so here generated 1000 data points from the normal distribution. Okay, so that is what we have provided here. And since we don't have the information on the number of groups to divide our data into, we use the histogram instead of a simple bar chart. And here we draw the histogram by using this the function. Okay, so the option here we have just provided as like the width, the color, and yes, of course, the alpha are used to adjust the width of the bar. So their colors and color transparency or respectively, yes, here we have just provided. And next, yes, dear friend, here I just want to add up one more thing. So when we just it is important to know that there is a close link between this frequency distribution and towards this probability, mass, and density function. So if we normalize the frequency of occurrence given on this y-axis of a frequency distribution plot, either bar chart or histogram, whatever we get the normalized or relative frequency. Normalized or relative frequency. So the sum of all the relative frequency of occurrence of all the event or group of data equals to 1. So we also know that the sum of probabilities of all the possible outcomes related to the values of random variable is also 1. So thus, once we have a frequency distribution plot of a random variable, we normalize it to the y-axis. Okay, so we normalize it towards the axis here y, and that is we get the relative frequency. So in this way, we obtain the probability function of the random variable. So now, if the random variable is discrete, we get the probability of mass function. So for continuous random variable, we get the probability density function. Of course, we are also going to discuss in detail in the next probability functionality. So kindly just don't worry about that. Anyhow, again, I'm just going to revisit that. Okay, and yes, let me just have that cumulative. So here, before going to cumulative, let us just have the above normal distribution of that function. So here it is a normal distribution of it, and here it is normalized histogram. Okay, here it just shows the normalized histogram. So which we just have this, and towards this histogram, kindly just, I'm just scrolling up and down to show what is the exact data and what we just got. Okay. Yes, let me just jump on towards the cumulative frequency distribution, dear friend. And yes, cumulative frequency distribution represents the sum of frequency of occurrence of a group and all groups below it in a frequency distribution. So this implies that we add up the frequency of all the groups below a certain group to find the cumulative frequency of that. And yeah, we just make use of the same example. See here. Here, if I just go with this, so here let me have the cumulative frequency. So at this point, we don't have any of the thing to it, summation. Okay, we have to find out the number of people who have their weight. For an example, if I just want to go for this particular, who have this, yeah, I have to make this is my mid value. So in such a case, first of all, let me just calculate the cumulative frequency. So at this point, 4 plus 15, here I just get 19. 19 plus 29, it is 39. 39 plus 22, it is 61. And here it is 66. And lastly, it is 68. So this is what the cumulative frequency. And in such a case, if I just want to, who have their weights up to 70 kg. Okay, so we have to add the frequency of the people in the range that is less than towards this one, less than 50 or 50 plus and 60 plus. So in this we have the cumulative frequency as like 39. Okay, so 39. Okay, let me just have this in the Python program. So here we have just made the code plot here. The same thing it was specified, and kindly just observe. Here we have given the cumulative frequency of this. Okay, and with this, let me just draw the frequency distribution. And kindly just observe, we are going to have weight range and the cumulative frequency students, not the number of students. We are just going to have this cumulative frequency distribution. So here X label, Y label and titles are provided. So let me just observe the chart. So here we go with this. So the output of the program just shows that the cumulative distribution is an increasing function, because the frequency of occurrence is never negative. Okay, so for the sake of completeness, we plot the cumulative frequency distribution as a continuous line. Suppose we want to know the number or the percentage of people among a group who own at least a specific number of car, or we have a total of 600 people who have at least one car. Let me just plot it in that manner, so that we can personally, or we can just make a customized functionality of a cumulative frequency. Okay, so let me just take that part and give an output. So here, as I have specified, a count of people here as like 600. Okay, and who have at least one car. So that is what the number. And let me just have people car data. That is number of cars as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And people having number of cars, that is 300. And yes, of course, it's a number. So 300, it is 150, 100. And yes, dear friends, we are here to creating this data. Here it is as like a dictionary. Okay, and we need to store this data in a dictionary, and let me just compute its frequency distribution by making it in a data frame by using a pandas. Okay, so this exact data I'm just passing it towards as like a data frame. And yeah, it is plotted as like a bar chart. First of all, we are just going to view only, nothing much more thing we observe. It is just an thing to have what is the exact plot we are, the data we have. Okay, nothing much functionalities here. And let me just first of all observe it. So see here, number of cars, people having number of cars, just what we have in a dictionary, we are just plotting it here and making use of the bar chart. We are seeing the chart here. So this is what, so having only one car, yeah, it is nearing 300 persons are having only one car, and 150 members are having more than one, that is 2 cars they are having. And the number of 3, so having 3 cars, it is 100 members having 3 cars, and 15 members having 3 plus us like 4 cars, and 10 members are having 5 cars. So that is what here we have. And for this, let me just plot the cumulative frequency. Here we are just having only the frequency. Let me just have the cumulative frequency. So for making cumulative frequency, here we are just going to for cumulative sum of. Okay, so cumulative sum of what we just get, of course, we just resultant with the last which we just have here. So of course, after accumulating, we just get the 600 numbers of people. That is what the distribution. So yes, dear friend, once I just execute and I just let you know, and here it is nothing much, number of cars and total people. Okay, so we are making an table. So people of cars, and here it is the total people. So first of all, it is 300, 300 plus 150, 450 plus 100, it is 550, and 550 plus 15, it is 565, 565 plus 10, 575. So that is what it just, and till end it just comes under 600. And here, kindly just observe the cumulative frequency distribution plot of a random variable here with a normalized y-axis, that is relative frequency, gives us an cumulative distribution function. So here, if we dividing it from this, if we just dividing it from this towards the third, which with the previous one, if we just divide it to this total number of people and that number of having of the car, okay, so it results in the normalized y-axis. So hence what we just get, yeah, there we just get the cumulative distribution frequency. And if you want to have it mathematically, yes, I just give you a small mathematical one second. So give you a mathematical thing. Yes, when you just go towards that cumulative distribution function, yeah, you have to specify mathematically as like f of x. Sorry, here it is upper x. So yes, here it is the exact x, that is the random variable, and probability of x, that is less than or equal towards the variable, that is less than the value x. So this is how it is mathematically specified. And of course, dear friends, where this f of x is the cumulative distribution function, and to that right hand side of the equation, that is says that probability of this random variable x having any value equal to or less than this value x. Okay, yes, dear friend, of course, we have had a good session, I think so, related towards the statistics and probability. Yeah, still more to go. Remember, dear friends, statistic is not just about numbers. It's about making informed decision based on data. Okay, so keep practicing and applying these concepts to strengthen your analytical skills. And yes, dear friend, if you have any doubts or if you want any particular clarification, kindly put it on towards the comment box so that I can just get it clarified then and there. And looking forward to our next session, where we will continue build on this foundation with more complex and interesting statistics and probability technique. Yeah. See you in next video. Thank you, dear friends, and happy learning.